So, welcome to this webinar on Mission Control and Weblogic. My name's Mike Croft. I'm part of the Managed Services team here at C2B2. And my aim today is going to be to introduce a little bit about JRockit's Mission Control tool, give an overview of how it can be used to troubleshoot common problems with applications on Weblogic, and give you a little demo as well. So I'll talk first about other tools that come with JRockit and how they also relate to troubleshooting, and then give an outline of the Mission Control tool itself. Once you're familiar with some of the features that are available, I've listed three related but distinct scenarios that Mission Control can help with, particularly in the diagnosis of problems. So I'll be focusing today on general performance problems and memory issues. To kick us off though, let's take a look at the extra tools that come with JRockit. So what utilities are included in JRockit's JDK? Well, the most obvious is Mission Control. That's what this webinar is all about. But aside from that, there's also JRCMD, which is a command line utility. And it's used to execute commands against the JRockit JVM. You can use it to start flight recordings, which we'll talk about in a moment. You can use it to initiate thread dumps, heap dumps, and to print out general statistics about running processes. There's also more generic JVM utilities, such as JStat, which gives you live GC data via the console, and others like JPS or JHAT. Now my colleague Matt Brazier has already done a webinar back in August on this very issue, so I won't go into any more details on that. If you do want to find out more about other utilities that are included, do please look at our previously recorded webinars. I would highly recommend it. So is this any different to the normal hotspot JDK? Well, yes. For one thing, not all of the tools that come with the JDK from Sun or from Oracle's Sun at the moment, not all of those utilities come with the JRockit JDK. For instance, there's no JVisual VM. Now the reason for this is that a lot of the functionality in JVisual VM is replicated in Mission Control anyway, and I may say done better. Now there is one small caveat to that, in that there are licensing costs in Mission Control, so do make sure that you're aware of those costs before choosing to go with that rather than JRockit. Onto Mission Control then. Mission Control provides several core functions: the console, flight recorder, and the memleak tool, memory leak analyzer, which, as the name suggests, help to get to the bottom of memory leaks. So for the console then, we can see live JVM statistics. These are just graphs and metrics about either local or remote systems. There is a facility to connect to any server that you provide the IP and correct port number to. Now that does require you to have set up remote management on your remote JVM. That won't work unless you've explicitly set it up. But it is very useful if you need to look at live statistics from a production server where you don't really want to be running this sort of quite intensive graphical process. It'll give you basic JMX interaction through the use of MBeans. It is rudimentary in comparison to dedicated monitoring tools like RHQ, for instance, or Hyperic, but it can be quite useful if you're just trying to diagnose a problem and you don't really want all the extra added functionality that one of those full-featured monitoring tools will give you. If you just want the basics, so for instance you might be wanting to capture an intermittent problem, something that only happens every so often, to no specific time scale. You can't really predict when it's going to happen. You can configure triggers and alerts and try and capture a bit of diagnosis when that problem reoccurs. The available runtime data in the console, it's mostly just a more in-depth look at the live metrics that are provided on the main dashboard, like for instance memory, CPU, and you can even get a stack trace on specific threads, which is quite interesting if you're seeing certain problems with, for instance, messages in your OSB. You can look at the individual threads for that. It also gives you the ability to profile methods or exceptions and even execute commands. So now I'm going to go through a few screenshots of the console tool. I'll just talk a little bit about each screenshot and some of the key features. Now I'm not going to cover absolutely everything because it is a really big full-featured product, and it would take an awfully long time to cover everything. So I'll just give you the highlights, and then we'll look into it in the demo. So here, this is the main dashboard for the console. As you can see down the left-hand side, we've got 4 different views: the general view, MBean's view, runtime view, and advanced view. They're all fairly self-explanatory, perhaps not advanced, but we'll take a look at each. The general tab isn't entirely interesting, but it does give you a good quick look at how the thing's behaving, how much CPU is taken up by the machine as a whole, and specifically the JVM, and how memory is doing. For MBeans, we've got a list of MBeans down the left. I've just chosen garbage collector for an example, and you can see for each one we can view details about the MBean. We can look at the notifications that are provided, and just over here on the right there's a box here that we can tick to subscribe to these notifications. They won't appear unless that is ticked. Further down we've got a list of some of the notifications that have appeared after I've subscribed. As you can see, the garbage collector is running every few seconds here, and we can see that by the message this is just a normal garbage collection, which is what we'd expect the garbage collector to do. So that's just an example of the sort of thing that you can do with MBeans. Now that's the browser. There's also the tab here to the right, which is the triggers tab. Now here is where it gets a little bit more powerful in your diagnosis. We've got a list of available trigger rules. Now for each of these we can add new ones, edit them, rename them. It's very versatile. But just by way of an example, if you were to click on, for instance, the deadlocked threads one provided in the Java SE folder, we can see that you can change the action that happens, change the condition on which that action is invoked, and change other constraints about the rule. Now here, because this is the deadlocked threads rule, I would guess you probably would want to look at a thread stack dump. So that would give you a good idea of how to look through any deadlocked threads, find out anything that doesn't look too healthy in your application. And obviously you can also configure where the logs are written to, and whether a system alert is created. It's very versatile, but again, not as full-featured as a full monitoring program. Here we can see the runtime view. There are 4 tabs down here. I've not got screenshots for the first 3 since we've already seen that information in the general tab. There's a little bit more detail there, but it's not what we want to concentrate on today. In the threads view, however, for each thread that's going through, we can see the stack trace. Here's an example of just a generic Weblogic thread. All these execute thread 7 for Q, Weblogic kernel default. These are just normal work threads from Weblogic. So if we're seeing that a lot of messages or a lot of workloads are seeing a similar problem, we might want to look through here, look at the stack trace for each, see if we can see any commonality between anything that's going wrong. In the Advanced tab, we've got the method profiler and the exception count profiler. we can start this and stop this, and it will only record results when it's actually explicitly told to run. It's not running by default. For diagnostic commands, any of you that have already used the JRCMD tool will recognize a few of these diagnostic commands. So check flight recording, list VM flags. These are common ones that are executed through JRCMD. The advantage of doing it through here is purely for the graphical interface, and obviously if you are looking through a remote system, you're going to want to have the ability to execute a command through the same system that you're using for diagnosis without having to open up a terminal and connect to the system, make sure that you find where the bin directory is and execute the commands yourself. This sort of takes out a little bit of the errors in typing on the console. I myself, I'm used to using graphical interfaces. I much prefer it. And if that's something that you prefer as well, this is a great tool to use. Here we've got informational commands. There's also, if you were to scroll down this list, more commands on taking a thread dump or executing a heap dump. Now on to the memory leak detector. This is a similar sort of thing to the console. If I just go back one slide, you can see in my screenshot I've got a second window open here with a very similar looking icon. Now that's actually not the same thing open again. That's your memory leak detector tab. So what that does is it will show you the overall trend, which is the growth rate of each type or class, rather than just the percentage of the heap they take up. And what that does is stops common classes, so for example char arrays, from appearing at the top of your list of classes that are in your heap. And that obviously gives you a slightly cleaner interface. It will give you a visual representation of hot objects. I'll give you an example of that in a minute. And you can look at these either by type or by instance. Now by type you'd want to look at how each class is referenced by other classes, and that's for all instances of the class, or you can even drill down to each instance. So for commonly used classes, so perhaps a java.lang class, you can see just the instances that are used by your application rather than those instances which are used by the system. And finally, it also shows where objects are allocated. So in other words, you can see the stack trace for each method which is holding an instance of the type that you're interested in, and what percentage of instances are held by each method. And we'll look at that in just a moment too. So here's the screenshot. Here's showing the trend analysis. So this is the first thing that you'll look at when you open up your memory leak detector. And you can see there are a couple of columns here with a bit of highlighting on. Now, as the analyzer is running, you can see in the top right here we've got a play button, pause and stop. Now by default this is always playing as you open up the memory leak detector, and all this data here is very dynamic. It changes as you're watching it. So each of these sort of reddish pink highlighted sections, these are showing increases, delta increases from the last time the measurement was taken. So we can see that for each snapshot between now and the last time, the java.lang.object array has grown on the heap by 0.34 bytes. It's now 9% of the heap. It's the largest thing on the heap at the moment. And you can see exactly what number of those objects are on the heap. Now it also shows things that have decreased as well. So when the garbage collector runs, it will remove some of these and the amount of that object will go down, and those are shown in blue. So here's a picture of what would happen if you were to right click on one of these, and this one I've looked at java.util.hashmap. You can right click and add to type graph, which is this screen, and you can see over here on the right this blue shaded class. This is blue because it's shrunk in the heap. There are fewer of them when that snapshot was taken than the previous one. But there's a little icon that you might just be able to see on the broadcast there, which is grey here because it's been expanded. But everywhere where it's green, you can click on it and it'll open up the top hot classes for that particular parent class. So I've expanded this and then seen that there's two red highlighted classes. So expanded both of these. I've seen both of them are related to java.lang.object. You can expand that and you get down to java.util.treemap $node. And although this is just a very generic example, it's objects that are used by the system. You can see how if this was a class that's written by yourself, one from your application, you can see which parts of that class, which objects it's holding are the really hot ones, the ones that are really growing on the heap. So for any sort of memory leak that you're suspecting, keep your eyes out for anything that's red. And the redder it is, the more of a suspect it is for a memory leak. Now here, it looks like a very similar view. It's subtly different. Rather than looking at the class as a whole, we're looking at a particular instance of the class. So in your trend view, you can right-click one of the classes and view instances. This gives you the left-hand pane where I've got a list of specific objects. Now each of these are a specific instance, and it tells you how much data is kept in that instance. So I've picked a slightly larger one, just over a megabyte, and here it gives you the same sort of interface, but this is again showing you individual instances. So we've got a particular instance of array list, which is referenced by a particular instance of this is the entire class, the mbean server factory. And we've got another particular instance of java.lang.object down here. So once you've got a little bit more detail about where your potential memory leaks are, this is where to start looking next. And finally, this is the object allocation, and you can see that these are just java.lang.objects again. We've got this percentage column. Now this tells you what percentage of the heap, what percentage of the total number of that class is called by each method. So here we've got java.io.object output stream .default write fields, which is 73.13%, and of its children, this .write serial data is holding 96%, and so on. So we can see where all of the main objects on the heap are held within each method, and you can filter those through your own particular classes. So you can search for your own classes that you've written in your own applications based on your suspects for memory leaks. On to Flight Recorder then. Formerly known as JRA Recorder, some of you may know it as JRA Recorder. In JRockit revision R28, that's changed. Now that the tool was originally JRA Recorder because it stood for JRockit Runtime Analyzer, which was the old name for Mission Control and its tools. But since more features have been added, Oracle have rebranded it to reflect these upgrades. Now it does, Flight Recorder does provide similar data to the console view, but this is with a crucial exception. This is historical data that we're looking at, not live data. So it's used in a very different way. This is much more targeted towards post-incident investigation. You may also want to use it to review any periods of poor performance. Perhaps your business use case involves seasonal activity. We're currently coming up to Christmas. An online retailer might want to review any periods of poor performance in the run-up to Christmas that might be cause for concern down the line when it starts getting to the last date for shipping. So onwards, we'll look at identifying problems in applications, and we're going to be using Flight Recorder for this. So some of the things that you might want to, or some common problems that you might want to use Flight Recorder to look for is to detect memory leaks. We've already seen memory leak detector. That's primarily for, well, it is for use with live data, not flight recordings. You can also use Flight Recorder to diagnose poor performance or just identify any hot code, any code that's using up an awful lot of the CPU. So now it's demo time. So what I'll do is I'll just switch over to my JRockit Mission Control. This is the main dashboard as you would open a flight recording. I've got 3 open here, and I'm just going to take you through a little look at how you would potentially diagnose a problem. Now I've got 3 for very good reasons. Each of these relates to a specific problem. I've written a blog using similar techniques where I've written a servlet application which will deliberately cause a problem in our application. So I'm going to show you how flight recording can help me discover which of my problem servlets is causing the errors. So on first opening for this first flight recording, we can see immediately that we're looking at from 1517 to 1518. It's 1 minute long, and there are an awful lot of events that are taking place here. Now, it should also be noted that these this event graph here, it's more of a sketch graph really. This is only showing you the events that make up the overview tab, as you can see that tooltip there, which means it's looking at CPU usage, it's looking at memory, garbage collection events, the really sort of common things. So we can see heap usage as well. It's grown a little bit, but if we look at the actual numbers by how much that's grown, in terms of actual size, that's not a big growth, not grown very much at all, and it is just over a minute, so I'm not too concerned about that. So let's have a look, see where if we can find out where all these events are coming from. Let's first take a look at the events view. Now by default, selected is the Java application events. Now these are all thread events, so we've got socket reads, thread sleeps, thread ends, thread starts, thread waits. What we can also do is add specific to Weblogic server events. We can add specific to the Java virtual machine events, and we can take things away. There are a few different tabs to look at. I'm going to open up the graph. So here we can see there's an awful lot of whatever this green thing is. Now we can hover over each of these colors and there'll be a handy tooltip. You can see in that thread there is no events for green. So this is what the green color means. There are no events, nothing is happening there. So let's look at another color. We've got a blue color there, that's the JVM wait, which is happening a lot. So we've got a lot of threads that are just waiting. We've got a lot of threads that are just doing nothing. So that purple JVM mutex, that's not really doing much at all. The other color that we've got a lot of is red on this particular thread here. So it looks like red is a garbage collection event. So we've got an awful lot of garbage collection. What we can do also is click and drag to zoom in on each of these sections. And we can see that there's an awful lot of garbage collection. So let's have a look at our memory and see how that correlates with how our memory is being used. This is the GC tab, and we can see that there are a lot of garbage collection events. If we look at the GC request trace tree, this shows where in the code a GC was triggered, and we can immediately see java.lang.runtime.gc. Now that's unusual, and if we drill down, we can see an application's been calling system.gc, and it's our servlet, servlet 1, that I've deployed, and that's calling a lot of system.gc. You can see over here on the right the count is 3,500 times, which over a 1 minute period is absolutely massive. Let's have a look at the GC graph. You can see each of these red columns on this graph is GC pause time. So we've got an awful lot of young collection, and you can see a couple of big pauses here. This is an old collection, and that will be because at the start and at the end of a flight recording, a full GC is executed. If this was a real-life system, some other things that might be interesting, we can see pause times. So we can actually order that by pause time as well. We can see the maximum pause time is 348 seconds, and it's an old collection. We can see details about the old collection, what strategy it's on. We can see any details about compaction, whether it was compacting or not. And we can also see more details about the heap. Now this isn't very interesting at the moment because with the JVM only doing GC events, that there's no real heap data to show over a 1 minute period. There's a little bit of details in this tab, but we'll take a look at the next problem, servlet, first. So just by first glance at this this next servlet, this next flight recording, we've got quite high CPU usage. I think higher than the last one where we got constant GC happening. If we look at the general tab and we look at the overview CPU usage, so we've got quite a lot of JVM activity for constant GCs, but there's a little bit of leeway there. On this next one, we're using pretty much 100% just in our JVM and application. So let's go straight to our CPU and threads pane, and the overview here you can see much more clearly this massive blue block is just our applications that are deployed. Now in this scenario I only had one application deployed, so this is quite obviously that all this is being caused by my application. It's just really hammering the CPU. But let's just assume that I've got more than one application and we're trying to find what's going on. If we look at hot threads, we can see all of these, which I mentioned before, are standard Weblogic work threads. All of these are referring to servlet 3. Now we can see there's a high sample count and a very high percentage for just 48. So this is using up an awful lot of our CPU, and it's almost certain that it's where we should be looking at this stage. It's absolutely our best candidate for the culprit. Now I should mention also at this point, in the real world, if you've got an awful lot of these threads, you're going to want to filter things. So you can either filter on the specific thread, so you might want to only look at these threads which are Weblogic work threads, where your application will be most of the time, or you can filter by sample count. Let's just do an example. We want to filter all threads which are greater than 11, and then it gets rid of all the detritus from the end, and we only see the really high sample counts. So on to the next and final one. Now this one is over a longer period. The first two were over just a minute. This one is over 10 minutes. You can see the recording starts at 10:23 and ends at 10:33. You can see there's some CPU usage, but that's quite low. So I won't be looking at any sort of high CPU usage, anything like that. Let's look at the heap usage, and that's quite interesting. We've got our blue line here is heap usage, and that's increasing throughout the whole time that we're recording. So let's look at our memory, and let's look at the heap contents, handily already on that tab. You can see quite clearly in this tab that this green section here is the used heap, the blue is the total heap size, so the amount of blue left is the free heap. And you can see that it's constantly increasing. This is quite clearly a memory leak, and this is where we would want to be using memleak detector, particularly if this is a business critical application that you really can't take down. You might find that you just have to run with this application and keep restarting the server just to start with no heap, just to really kill everything that's on there and start from fresh again. So looking at the free memory distribution, again, this is just a little bit more detail that you might want to look at in the real world, but it's quite clear what the problem is for our purposes. In object statistics, we can see this byte here, byte array. It's an absolutely huge percentage of the heap. Now these sort of low-level primitives you tend to see quite a lot of anyway, particularly char arrays. But 78.4% is an absolutely huge percentage. So we're going to be looking for where this is coming from, what's using up that byte array. Looking into allocation then, we'll see allocation by thread, and we can see there's nothing particularly interesting there. This is all just normal system stuff. We've only got one sample, and that's not going to show us anything particularly useful. So back into the overview. Sorry, yes, that's the final problem. So that's just to give you an idea of how to look at these slow memory leaks. So finally then, let's just go for a quick summary of the things that we've covered. Crucially, the main thing that we've covered is how versatile mission control is. I know I did skim over an awful lot there. There wasn't really much time to go into a huge amount of detail, but it must be noted that mission control can be used for almost all performance related diagnostics and even monitoring, which is a lot more than most other performance tools that are out there. It really is something that I would very highly recommend that you get a hold of, have a look through. There is a developer license that's available, which is absolutely free for you to download, poke around, analyze some of your own applications and just see if you can find any benefit to it. If you already have JRockit with Mission Control, which I mentioned includes a lot of updates. It also enables you to take hprof heap dumps. For those of you who are used to using IBM's memory analyzer, that accepts HPROF heat dumps. So you can use your existing tools there. So whether or not you're going to be using the mission control, it is still recommended that you go to R28 for the extra functionality there. And also see our blog. There is a similar blog post about this sort of thing to give you a different format of seeing the capabilities of JRockit Mission Control. And finally, feedback. Please let us know how you found this webinar, whether it was the right level for you or not, or whether you want more detail, more depth. Just send me an email, mcroft@c2b2.co.uk. And finally, thanks for listening.